We are going to study about shear force and bending moment. Okay, this is our part one. Okay, part one. See, basically, we will have four parts in this. Okay, the first part will be about general equilibrium equations, then the various kind of supports, then the various kinds of beams, and the various kinds of loads. Okay, and the second part will be basically about the starting of bending moment and shear force, that is like the helping aids of that, the sign conventions and all. Okay, how shear force is positive, and how bending moment diagram, which side is positive, like that. Okay, that will be basically regarding the second part, and the third part will be regarding various yeah, problems in bending moment and shear force. Okay, and the fourth part will be regarding, this will be simple problems. Okay, very simple basic problems, and the fourth one will be regarding various objective questions. Okay, previous year's objective questions regarding bending moment and shear force. Okay, so these will be the four sections in bending moment and shear force chapter. And see, if you want to study bending moment and shear force in a very proper manner, you will have to follow these four videos very correctly. Okay, if you miss some part of it, then you won't understand anything. So it will be like in a continuous manner. So you should not skip any of these parts. Okay, so let us start with the first part. Okay, so first one is equilibrium equations. Equilibrium equations. See, the basic equilibrium equations are sum of force is equal to 0 and sum of moment is equal to 0. See, if for one dimensional, we have like time members. See, in this time member, see, forces we are giving like this. Okay, in this we will have x directional force. Sigma sum of x directional force is equal to 0. This will be our equilibrium equation. Okay, and if it's for 2D, this is our like general case is what we do, like in case of beams and all. The problems will be mainly asked in 2D. So in those cases, we will have two dimension, means sigma sum of forces equal to 0, means sigma f of x is equal to 0 and sigma f of y is equal to 0 and sigma m of moment about z axis is equal to 0. So this will be the equilibrium equation, three equilibrium equations in 2D. And when we are dealing with three dimensions, we will have sum of forces in x, y, and z direction is equal to 0. Okay, and we will have sum of moment about x, y, and z direction is equal to 0. Okay, that will be regarding three dimensions. Okay, we will now do very simple problems. Okay, to make sure that you understand how to solve reactions. Okay, so we will do very simple problem regarding that. Okay, so suppose the first one. See, like this we are taking. Okay, this is a pin joint and this is a pin joint and this is a roller joint. Okay, in that case, suppose we are giving a load like this W. Okay, and we are having a UDL like this. Suppose that is of W per unit meter. Okay, UDL you will represent like W per unit meter, and this distance is suppose 1 meter, and this distance is 1 meter. This distance is 1 meter. Okay, we have to solve this problem. Okay, so the equilibrium equations we have to use for this. So the first equilibrium equations we have to use is sigma f of y is equal to 0, because sum of sigma x is equal to, sigma f of x is equal to 0 we can't use here because x direction forces are 0. So only this equation can be used here. So when we use that, see, suppose we will have an unknown reaction here. Suppose this is A support and this is B support. This point is C, this point is D. Okay, so here we have RA and here we have reaction B. Okay, so total forces going up is equal to total forces moving up. That is what it means by sigma f of y is equal to 0. We are taking this as our y direction. So what will happen? RA plus RB is equal to, so what force is going down? W plus W per meter run. So W into 1. That is this 1 meter. Okay. W, this load W into this distance 1 meter. Okay. So we will have 2W. RA plus RB is equal to 2W. Then the next one will be sum of moment about z-axis equal to 0. Okay, this is our x direction, this is our y direction. So perpendicular direction, perpendicular to this plane will be z direction. So moment about z direction like this is equal to 0. So what are those moments? See, because of this RA, suppose we are taking B point. Okay, so we are taking moment about this B. Okay, sigma m of B is equal to 0. So about this Z axis, what are these moments? RA into, see the distance. See, we are taking this B point, okay? So about B, what all are there? See, RA into this distance. What is this distance? 3 meter. So RA into 3 meter plus W into, see the direction. If you are taking clockwise as positive, then maintain that sign convention. Okay, so RA into this distance, and so that is clockwise, so that is positive. And see this one, because of this W, if we move till B, how can we move? We can move like this only, na? So what direction is this? That is a negative direction, na? So we'll have to put negative there. So W into that distance, see that is 2 meter, so into 2. Then what? Then this UDL. Because of this UDL, you will have, see, this UDL is acting like this only. So it will have an anti-clockwise moment. So minus W into 1 meter is the total load into centroidal distance. See, the load centroid is here. So this distance is 0.5. Okay, into 0.5. That is equal to 0, because total moment at B is a 0, because B is a roller support. We will discuss about this later, but let me let me make clear about these, how to solve this. We will discuss about these supports in this lecture itself very clearly. Okay, so that is it. So 3 into RA minus 2W minus 0.5 W is equal to 0. So we will have RA is equal to 2.5 by 3 W. Okay, then if RA is this value, then putting in this, we can solve RB. RB is equal to 2W minus RA. So we can solve like that. So in this simple manner, we can solve all the reactions. Okay, we can find out all the reactions. Okay, now the next one. So this is regarding equilibrium equations. Okay, then the next part will be like, we'll have to discuss about supports. Okay, various kind of supports. So what are the various kinds of supports? First one is a roller support. Okay, roller support. See, roller support is something like, see, like this. There will be roller. Okay, like this would be roller support. Here it will roll. If this is a ground provided, this roller support can roll over this. Okay, so it has a resistance only in this direction. That means that it has reaction or resistance in this direction. So vertical reaction is present here, but horizontally it can move like this. Okay, that is regarding roller support. And the second one is hinge support. Hinge support. This is present actually in old bridges. Okay. And hinge support, we put it like this. Okay. If if we are putting this on the ground, see, here it can resist in two directions, in vertical and horizontal direction. This won't move, but this can't take any moment. If we are providing a moment like this, then it will be like move like this. Okay, it cannot resist any moment. So that is regarding hinge support. In our laptop and all, we usually have hinge support. In the doors, we have hinge support. That is, it can rotate, but it cannot move. It cannot translate, or it cannot move in any direction. Okay, it just can rotate. So that is a hinge support. Okay. Then the next one is regarding third one. It is regarding fixed support. Fixed support. See, fixed support we represent like this. It is fixed. It can resist both the reactions, both the horizontal and vertical. Sorry, it can resist in both horizontal and vertical direction. It means that it has horizontal and vertical reaction, and it can resist moment also. It can resist moment also. Okay, that is regarding fixed support. So then the next one, fourth one, internal hinge. Internal hinge. Okay. This internal hinge, internally we'll have a hinge. Okay. In the elbows and all, we have that. Okay. See, in our hands and all, this point. Okay. If your fingers are, I'm not good at drawing. See, we have, oh my God, one, one finger is missing. Okay, fine. See, here, at this joint, we have, see, we can rotate our hand like this, na? So that kind of hinge, that is internal hinge. It is like internally it will transfer its axial forces and transverse forces, but it cannot transfer the moment. That is, moment is equal to zero at this point. It is like individually it can take a moment on its own. This part can rotate like this part can rotate like this, whatever way it want. Okay, so moment is not transferred. Moment is equal to zero at this point. Okay, so that is the regarding internal hinge. And then we will have shear hinges. Okay, shear hinges. Shear hinges. Shear hinges are of two type, axial and transverse. Okay, axial and transverse. Axial means that axially it can move. See, in the shock absorbers and all, it can move like this. Now, this one, this you have rollers like this. It can move like this. So axially it can move. So it's H is equal to horizontal. Horizontally, you can resistance is zero. You can horizontally move anyways. And transverse means that perpendicular to the axis. See, if this is the axis of the member, perpendicular to that axis, it can move. That is the transverse shear hinge. Okay, like this, it can move. So that is vertical is equal to zero here. So that is the case. This is in our rolling shutters. Rolling shutters, see here, if you will have two supports like this, shutter can move like this, no? It can move like this. Perpendicular to the axis, it can move like this. So that is a transverse shear case, okay? Then the next one, that is the sixth one, that are links, okay? Links are like this, it is linked. Okay, axial forces it can transfer. See here, it can transfer the axial forces. See, for the example of this is a truss. Okay, truss member is like this, um, and if we give a force like this will end up in compression of these members. Okay, forces are taken like compression and tension in these members, so it can transfer forces in axial way. That is the example of links. Okay, um, that is the. Then we'll have to discuss about various types of loads. Types of loads. First one is a point load. See, here we are supposing a simply supported beam. Okay, this is a simply supported beam. You have a load, point load W here. What does it mean by a point load? Now, what is the physical significance of a point load? Physical, it doesn't mean that it is like like a needle load in a very small, minute place it is acting. It doesn't mean that. Okay, compared to the surface area of the member, this load is only in a small area. That is what it means by a point load. Like on an earth, if an elephant step, see that elephant step, that is not a point load. Na? It's having this much of area of acting. But compared to the surface of earth, this is like a point load. That is what it means by a point load. Okay. Then the second one is UDL. UDL means uniformly distributed load. Okay, it is represented usually like this or like this. Okay, like this. W per unit run, W per unit meter. Like that it is represented. Usually, according to IS 875 Part 1, 1 is regarding dead load, 2 is regarding live load, 3 is regarding wind load, and 4 is regarding snow load. All these IS codes, these or consider all these loads as UDL. So UDL is our standard case, like okay. But earthquake load is like variable. Okay, it's varying. It cannot be considered like a UDL. Okay. Then the next one, third Third one is a uniformly varying load. Uniformly varying load. Okay. Uniformly varying load can be like like this. It is varying uniformly. Okay, from zero value to W per unit run, it is varying. And it can be also varying from starting from a particular value W1, it can vary like till W2. W2 per meter run. This per meter run. Okay. Like this also it can vary. So, example of this is that in a hydraulic body, okay, here water is there, and here the pressure will be like this, like this the pressure will be. If this is the height h, like this the pressure variation will be gamma W into h will be here. Okay, so this is the pressure variation here, and similarly in a retaining wall, see this is a retaining wall here, and there is a surcharge acting over here. So here the pressure distribution will be somewhat like this. Okay, so this is a case of uniformly this trapezoidal uniformly distributed load. Sorry, is trapezoidal uniformly varying load, and this is a case of triangular uniformly varying load. Okay, so that is it. Now we'll discuss about couple. Okay, fourth one, couple. Couple are equal and opposite forces separated by a distance. Okay, let us give this distance as A. If two forces are the P and they are equal, they are separated by a distance A. The net effect of this force is a moment. That moment will be like this. See the arrow mark of this. It will be like this. See like this, and that will be force into perpendicular distance. This P into perpendicular distance is A. So PA. See, in a concrete structure we will have the similar condition. See, here we have steel, and here we will have like tension will be there, and here we will have compression, and this will be separated by a lever arm Z. So CZ or TZ will be the moment developed. So similarly, that this is an example of couple. Okay, now we will have the next one. Actually, is not a kind of load. Bracket is like we'll have to discuss about bracket. This is not a kind of loading actually. So bracket will be like this is a condition. Okay, see here we have a bracket, and here we are providing a load like this. Okay, W. This distance is A. See here we will have to like in this member, this load is given in using a bracket. Okay, here the load is acting. So this load we will have to transfer to this point C, so that we can make this condition simple. So what will happen? See here W is there. Here if you give at the C point, if you give W like this way, See, this nullifies each other. Now you give W and W this way. So this nullifies, so there is no issue. And because of this W acting into distance A, you will have a moment. See, because of this arrow in this direction, you have moment like this, WA. So, so this is the condition here. So actually what will happen in this? It will be like W, 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 and a moment WA. So because see this is the net, okay, this is the net effect. So what can happen? This W and this W equal and opposite will cancel each other. So the net effect will be like there is a force W here and a moment WA here. Okay, this is the condition. Here we have bracket. So see this is the net effect on this beam because of this load on bracket. Okay, here there was a load that is transmitted here. Okay, so the load anywhere in the structure can be transmitted, and this load is called law of transmissibility. Law of transmissibility. We are transmitting the load. Okay, through a point load and a moment. This is called law of transmissibility. So that is it. Now we'll have to discuss about various types of beams. Types of beams. First one is a simply supported beam. Simply supported beam, we have already done a problem on it. See, one end there will be a hinge, the other end we'll have a roller. Okay, here reaction will be in two directions, here reaction will be only vertically. That is our first one. Then the second one will be a fixed support, fixed beam. Okay, fixed beam will be having fixes at both the ends. Okay, it will be resisting in three moment, vertical and vertical and horizontal forces. And the third one will be propped cantilever. Propped cantilever. Propped cantilever means it is fixed at one position and it is having roller in another portion. And the next one is a cantilever beam. Cantilever beam means it is fixed at one end and it's free in another end. So resistance is in three directions. Three reaction is in three. That is two horizontal and one horizontal, one vertical, and one moment. These are the resistance. Okay. Here M we represent, here V, here H. That is it. Now these are the cases. Then the next one will be uh, okay. So that is it. These are the very simple kinds. Okay. Simply supported, fixed, propped cantilever, cantilever. Okay. Now that is it. This is regarding the first part. Okay. Just follow the other parts also to have a very good idea about bending moment and shear force diagram. Do subscribe to my channel and press the bell icon if you haven't. Okay.